Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, it's a pleasure to have Yuri visiting us. He does a lot of super interesting work in networks, broadly speaking, bridges a lot of connections between social science and computer science. You know, he really started understanding a lot of interesting questions of how do you even analyze networks at various scales. Yuri's PhD work was with Christos Faloutsos at CMU, and then he was a postdoc with John Kleinberg, and now he is faculty at Stanford.
So. Okay, thank you. Great. Thank you very much, Shem and Jennifer and Christian, for the invitation. I'm very happy to be here. And what I prepared for today is a talk about trying to understand sort of human evaluations online and sort of doing little empirical experiments and trying to understand what's going on. And then I'll show you some cute applications and so on, right? But really, where I'll start is this kind of remarkable transformation of computing into this kind of where the social aspect of computing is getting stronger and stronger, right? And one of such cases is, for example, in many online applications today, sort of people express positive and negative attitudes or opinions and so on, right? And they express these opinions either through some kind of actions, right? Let's say giving star ratings to products, pressing like buttons everywhere on the web, or writing text reviews, comments, things like that, right? So these are all some kind of forums where people express their opinions online, right? And really, the success of many online applications is built on this idea that sort of people will tell you what they think about items, and once they tell you what they think about items, you can then build recommender systems. You can sort of use crowd as a filter to determine what are good pieces of content, what should be filtered out, what is spam, things like that, right? Sort of these evaluations today are super important, either sort of as training sets for machine learning algorithms, or for ways for communities to make certain decisions and so on. Right? And really, if you ask about human evaluations, then there are different things that humans evaluate online. Sort of, right? The most common one is where sort of people rate items. What I mean by that is when sort of people give, let's say, star ratings or pluses and minuses to microwaves, iPhones, things like that, right? Sort of items to which they don't relate, right? Products would be an example. A second example that sort of I will be focusing in this talk is when people evaluate other people, right? So now I'm not evaluating some microwave, but I'm evaluating some other person to whom I had maybe prior interaction and things like that, right? Sort of this will be the focus of this talk. And then the other thing that is very similar to this sort of users evaluating users is basically when users evaluate items created by other users. What are examples of these kinds of things? For example, in question answering websites, people ask questions, other users give answers, and then people sort of give thumbs up and thumbs down on those answers. So basically, they evaluate whether that answer was correct, was it good, and so on. On Amazon, for example, people vote whether reviews were helpful or not, right? So again, they are rating content produced by other users. Or in the opinions network, people say, was this product review sort of good or not, right? Sort of the focus of this talk will be user evaluations, either in this sense or when users evaluate content of other users. Yes?
What if the Amazon were also created by people?
Sorry?
What if the Amazon were also created by
people? Yes, but the thing I want to... You don't know the inventor of the microwave and say, oh, because you're a good guy, I like your microwave, right? So that's sort of the difference I want to make, right? So in all these cases, the idea will be you are basically either evaluating somebody who's a member of the community and not some external product that somehow came on the site. Okay?
Also on Amazon, like people review their own books. People buy their own books and post positive reviews.
Sure. For example, if you would go and see how people evaluate authors or books written by certain authors, that would be the case that could fall in this category, right? But evaluating an inventor of a Mac or something else, it's kind of hard. Okay. So I'll try to focus on these cases.
So eBay fits into some or both.
eBay, I think, so if you think of eBay as people giving trust edges, then it would fall here. If you think of eBay rating products that other people maybe sell or rating product reviews, it would fall into these categories. For me, what I will do at the end is I will abstract them to this level of saying one person evaluates another person. And when I say one person evaluates another person, this means I either evaluate you directly, I will make it precise what I mean by that, or I evaluate the piece of content that you created. Okay? So I'll make precise what I want, right? So when I say evaluate, right, there is many different things what I mean by that, right? Like, as I said, one person evaluates another person or a piece of content that this other person, member of the community, created. And evaluations can have sort of different meanings, right? I can say, I trust you, right? So one of the cases we will look at is this online product reviews community where people will say, I trust your product reviews, right? You can also look, for example, whether somebody agrees with someone or not, right? The other case where we will what we will look at is when people vote, whether other people should be admitted to become members of the community or not, right? Or another case is when people sort of evaluate other person's opinions or answers or reviews, whether they are useful or not, right? So those are sort of pieces of opinions that I'm interested in, right? And if you think about this, there are many sort of natural analogies that also happen in the real world, right? So, for example, things that would be analogous to the processes I want to study online are, for example, acceptances of papers or conferences to conferences or journals, right? I write a paper and now somebody else evaluates that paper and in some sense evaluates me also, right? Or funding grant proposals, or deciding who gets hired in academic departments and so on. And some of the things I will show you, I think you will be able to reflect back to this kind of real world analogies.
So do you have the special case where just one person decides whether somebody gets hired or receives a vote?
I will always sort of see votes, sort of some kind of result of a community process. So let me tell you what I will now look. So if I told you I'll be looking at these evaluations, what are sort of some central issues that I want to explore, right? So the first part of the talk and the longest sort of part, what I will spend on is basically trying to understand what kind of ingredients or factors lead or play a role when people evaluate each other. The other sort of what kind of biases are there, if you like. The other thing that I will do then is to ask, if I have lots of people express their opinions, how do I sort of create this kind of composite or aggregate descriptions that sort of accurately reflect the cumulative opinion of the community? And then for the last part of the talk, I'll be showing you examples of what if sort of these opinions or these evaluations have multiple dimensions to them, sort of they have multiple aspects. How can I reason about that? Okay, so the setting for this talk is I want to talk about people evaluating each other. They can do this directly, sort of by, let's say, voting or telling who they trust or who they don't, or by evaluating a piece of content that was produced by another member of community. That's what I sort of try to show with that bipartite graph, where sort of the idea is that red edges say that a particular node created a particular piece of community, and then other nodes sort of evaluate that piece of content, right? And the question is, if this is the setting I want to study, where does this happen online, right? And here are the data sets I will be talking about and sort of what I will be using to do data analysis. So the first thing I'll be talking about happens on Wikipedia. On Wikipedia, there is a group decision process that sort of leads to promotions of Wikipedia editors to become Wikipedia administrators, right? Sort of users with additional privileges. And the way the process works there is that some user gets nominated, and then other users come and explicitly vote in support or in the opposition of that candidate being promoted. And we have this kind of elections, tens of thousands of them, and overall we...
Are voters promoted? Administrators themselves or editors can vote?
No, anyone can come and vote. Any member of the community can come and can vote, so it's open to anyone. A certain person gets sort of put there to be a candidate for promotion. Other people come. There is this sort of Wikipedia webpage, and what you have to do is edit that webpage, enter your name and the time, and then you put yourself under the support or you put yourself under the oppose. So everything is public. It happens over time. When you come and vote, you see everything that happened so far.
Next to it, you picture a little graph. What are the edges in the graph in this example?
The reason why so a positive edge here would mean it's a directed edge, and a positive edge would mean that I voted in the support of the target, sort of I voted positively for the target to be to be promoted, and a negative edge means I oppose the target to be promoted.
The edge shot meant I voted.
I voted on that target.
But it's a very asymmetric thing where there are many more voters than people that are being voted about.
No, so we have around 10,000 people, and I think around more than 1,000 elections, for example, for English. And we did this for English, German, French, and Spanish Wikipedia. So most of the results that I'll show you just on Wikipedia. The same things will apply. For example, we also look at Stack Overflow, where Stack Overflow is a question answering community. Now people ask questions, people give answers, and then other people can say, this is a good question, this is a bad question, it's a good answer, it's a bad answer. So thumbs up, thumbs down. Again, the way I will be thinking about this is whenever I give a thumbs up to the particular question, I'm basically giving a positive edge to that author. I'm giving that author a positive evaluation. And the last case that I'll be talking about is this is an online community of product reviews where people create evaluations to each other and say what do I think of your product review. So basically people evaluate product reviews. So they evaluate the evaluations of the products. Again, and they give star ratings. Just for the purpose of the talk, I will use 5 stars as positive and 1 to 4 as negative, just because everything is 5 star.
A budget. In other words, it's not like Congress where you cannot, I mean, the number of people who will be voted in is not determined a priori, right? It could be in principle everybody, or it could be nobody.
Exactly. So the first decision you have to make is whether you will go and vote, and then the next decision is whether you will go this or that, right? So you have people first have to decide whether they care enough about this to go and actually express their opinion. Yeah?
How should you pick these data sets versus like something like YouTube? How do you decide these data sets?
The reason why I took these data sets is because on YouTube I don't have the data. I don't know how to get the data, right? Because I really want to know that user A voted on user B. I don't just ask how many votes this piece of content get. That's not what I'm interested in. I really want to know how did A vote on B. And for these guys gave us the dump of their database. These guys gave us the dump of the database, and this we were able to crawl. If you have connections to Google, I'd be super happy.
YouTube has it, right?
Oh yeah, they have it, but they won't give it to us, I think. Right? Okay, so again, what I said, so this is sort of the setting, what I want to do. First thing that I will talk about now is trying to understand sort of what all ingredients go into these evaluations, right? So my setting is the following. There's a user A that is evaluating user B. And basically what I would like to understand is what kind of properties of the evaluator A and the target B sort of affect A's vote. And I sort of, to give you a bit of a preview, what will happen is that sort of you have 2 fundamental properties. One I will call status, and the other one I will call similarity. So first, let me define these 2, and then I'll show you how they play and what can you do with them. Okay? So first, what will be the notion of status? So for now, for me, notion of status is, a level of recognition, merit, achievement, or reputation in the community. So to make this operational, what I will do is I will say for Wikipedia, this is the number of edits that you have created, right? It's sort of your seniority, whether you are an experienced editor, you contributed a lot, or you contributed little. I'm just sort of operationalizing this notion. Right? And then the other thing that I will do is something that I will call similarity, right? It's basically the idea how topically overlapping are the interests of users A and B, sort of the evaluator and the target, right? And this, again, what this will boil down to is, for example, the cosine similarity between the articles that you edited, right? So the idea is, how many articles have you do you have in common with that other person you are evaluating, right? Sort of, do you edit similar parts of Wikipedia or you edit different parts of Wikipedia, right? So I have similarity, which you can think of, how well do I know you, and status, what is your level of contribution, right? So in academic setting, this would mean sort of how many papers you have published or how many citations you got, and this would mean, are we in the same area? Do we publish at same conferences or not? Okay? So now the first question is, right, so I have this user A evaluating user B, and I can ask, what all goes into this process. And there are sort of two hypotheses, right? So the first hypothesis would be that, say, the probability that user B receives a positive vote sort of depends on the characteristics of user B, right? So, the idea would be to say there is some objective criteria for a user B to receive this positive vote. So in the case of Wikipedia elections, what this would mean, it would mean that, there is some kind of threshold that's sort of unwritten threshold that says if you've done this many contributions to Wikipedia in these different places, then you are good to be elected. Okay, so you could That would be what this hypothesis would say. The other hypothesis would say actually that probability that B receives the positive evaluation depends on sort of on the relationship between the voter and the candidate, right? And the idea is that sort of when a user A shows up to evaluate B, sort of he compares himself to the candidate B and then makes some kind of evaluation. And to show you a bit how, to get some insight, here is one thing that we looked at, right? So we ask, okay, how does the status of B affect A's evaluation, right? So status just means the number of edits on Wikipedia, right? And I have the graph on the right, and what this graph shows is the following. So this is the x-axis is the status of B, so the number of edits B has made, and this is the probability of B receiving a plus. So A is evaluating B, this is the status of B, and what I'm showing, what each line here makes the delta in the status to be constant, right? So if the delta is positive, this means that a high status person is evaluating a low status person, right? So the A minus B is positive, and this means that somebody of low status is evaluating a high status. But sort of I try to keep the difference constant while I increase the status of B. And what do you find, right? You find that these lines are flat. And what this tells me is two things, right? The first thing, basically, the probability of A giving B a plus sort of doesn't depend on A's status, right? So for a fixed difference, the probability remains flat, right? Which basically means that regardless of what is the status of B, people care not about the ratio, but about the absolute difference in the level of achievement between the two guys. Yes?
So why wouldn't you interpret it as just this is not status? The number of edits that you have is not status?
Why would
the number, like this is just suggestive that the number of edits that you do doesn't say anything about how good of an editor you are.
So you are saying that my notion of status may not be right.
Yeah.
Then the delta wouldn't predict.
So,
It's not
so one option is, so what's wrong with this? So you're saying that, you're saying because this is some random number, nothing really depends on this random number.
No,
but for example, it does, right? These are the people with sort of low status. These are people with high status, right? When you are evaluating somebody with high status, you are more positive when you are evaluating somebody with a low status, right?
Well, but
the other thing is what you can do, for example, if
the first thing is that you lump together a couple of different evaluations of people, and I'm not sure what is a plus supposed to mean on Stack Overflow, but if you say I'm voting on whether this person should be an editor or not, then there's probably some concerns for me as a Wikipedia user who cares enough to vote about it. And I'm not sure that the number of edits that you did is sort of the right sort of measure for your status. I would probably care more about whether you did good edits to important pages.
Oh, we did a lot. We did a lot of things here, right? So, for example, one thing that we looked at, we played a lot with different notions of status, and also when we were doing similarity, because we wanted sort of to capture the idea that exactly what you are arguing is, you know, if I just go and correct commas, then I really touched lots of articles, but I haven't made any significant contributions. The other sort of different notion of status that we used was to say in Wikipedia, other people can give you barn stars, right? Somebody can say, oh, I give you a barn star. I think you made good contribution. Here's a you know, little gift that you can put on your profile. And if you do that, use that as a notion of status, which means some recognition from other members of the community, these plots look very similar.
But I think it all ranges from something like 92% to 95%.
Yes.
So it seems very, very close to each other, right?
Yeah, but if I think I even have error bars, but you don't see them.
But how do you say it proves it? Because if I would make a statistic hypothesis that at 2000 they all converge, this curve looks very consistent with this hypothesis. So how do you say that this proves that it doesn't depend on B status? Because I would just have claimed, I now claim this proves that it converges.
So we are arguing whether these lines are straight or whether they are converging somewhere here.
Because if they're still moving up and down a little bit, and the way they move up and down is of the same order of magnitude as the difference.
I'm very sorry, this is real data. What I can argue, you know, is that there is some range where these things can be flat. Try to bear with me, it will make sense. What about that? Okay, so that's the first thing, right? Like, people, what this tells me, at least the way we interpret this, is that things are flat, which means that people really sort of are fixated on this difference in status. Okay? So that's the first thing. The other things that I would like to ask is in terms of similarity, right? So now I ask, have we edited similar articles or not? And here you could ask, and how does the probability of applause depend on this? And here you could have again sort of two hypotheses. One would be, I'm more supportive of targets in my area, right? If you are in my area, I'll be very positive towards you. Another sort of hypothesis you could make is, I'm very harsh against you, right? I know you, I know your weaknesses, so I'll go after you. What you find here is that.
Question about that
yeah?
second hypothesis. The motivation of that second hypothesis would lead me to think that actually the evaluation curve should be steeper, not that it should necessarily be harsher. The question is, if I know you, is that sort of better, or is that worse in terms of getting good evaluations, right? So if somebody says this person is really good, but you don't know them, right? So maybe that's sort of influences you more than if you really know, what that person did and so on and so forth. What this says is actually that the first hypothesis is true, right? So that the higher the similarity, the more positive are the votes, right? And these are different languages. Right? Sorry?
This is also with Wikipedia.
This is all Wikipedia.
So,
sorry, go ahead.
No, I'm just again just a little bit confused at the numbers. Before they seem to range between it seems that the average thing is 93% positive. Now it's 60%. So.
The reasons why this is also the case is.
I think it has to do with the low status people, which most of them.
I will come to the low status people.
The
so
91% etc. were the high status people. There were fewer data points.
Yeah, so you had sort of few data points there, right? The thing is, right? So there is lots of data here, and these people, the low status people, don't seem to be obeying my flatness, and I decided to throw that slide out.
So there is a whole bunch of junk.
Yeah, there is a lot. There is relatively lots of junk here.
It's actually not junk.
But
interested
data.
I wouldn't.
So
the majority of people, right?
I have a question on, if you go back to the previous slide. So certainly, their sense, as they're more similar, they're more they like each other more. But if you somehow, maybe what David is referring to, if you somehow correct for that, as you vary both of them simultaneously, what's the effect?
That's what I'm trying to show you. Not yet. Okay, yes.
Do you have negative votes as well?
Sorry?
Are there negative votes?
Yeah, of course.
So
any vote can either be positive or negative.
So why not split the voting into two stages? One, whether I decide to vote at all, and the second, whether I give you a positive vote?
That's not what the data was.
That's not
Yuri give his talk.
Right.
Instead of rewriting it on the fly.
So here I'm only looking at people that showed up to vote. I will later show you a plot that asks who are the people that show up to vote. Okay, so we know two things so far. People care about absolute status difference, and the more similar you are, the more likely you give a positive evaluation. Now, Sham's question, what happens if you put status and similarity together? And here's an interesting plot, right? So what I'm plotting now is the status difference between A and B. So this is when they have the same status, when A has high status, and when sort of A has low status, right? And B high. And what you see here is that when high similarity people evaluate each other, sort of the status difference doesn't seem to matter, right? While when low similarity people evaluate each other, the status difference seems to matter, right? Which sort of seems to say that when you know someone, you give your evaluation. When you don't know, when you don't know them, sort of you start using status as a proxy for their quality. Okay, so that's the first thing. And then the second thing that was also asked is who shows up to vote. So again, the same y-axis, the same x-axis, status difference, and here is similarity. And this is for Wikipedia. So what this means is that, right, this is when the status difference is high, right? And candidates sort of have intermediate status, right? They have contributed something to Wikipedia. So what this tells you is, right, that people who have much higher status than the candidate, basically they are similar to the guy, right? So they are evaluators' votes on the targets with sort of from the same area as their expertise, right? And you could see similar things from academic departments that
high status people are the high status people that get excited are similar, things like that. You know, people that don't know you do your paper count and make their opinion that way, and so on. Okay, so yeah.
Yeah, the y-axis is like differs between like 1% and 2%, right?
Yeah, these are angles. Right, so I
These
could
are
also
cosines, remember?
Yeah, these are cosines of very long vectors. I could, you know, before what I did here or a few slides back, I had percentiles to sort of stretch it out. Now I'm just showing you the absolute number.
Can you give a sense of how different that is qualitatively, that 0.18 to 0.0?
So here, like with this plot, we were super careful, and I think what we decided, we tried like super many things. We tried cosine. At the end, we tried cosines. We tried only taking, you know, the top 1,000 articles you edited, the ones where you created the most edits. We tried throwing away small edits. At the end, I think what is this is a cosines of binary vectors, where the idea is I will take your top 1,000, sort of the biggest 1,000 edits that you made, and that's like now a binary vector. What are the articles you touched?
Just qualitatively, are those really different? 18 to 13? How should I think about that difference?
I would think this is a significant difference, because this will allow me to explain something later. Okay, so that's the first thing. So this is what we know so far. So another thing I'd like to show you is this question, right? So if I showed you about the status and so on, then right, how does the probability of plus depend on this status difference, right? And what we know so far, you would expect that this sort of to somehow monotonically decrease, right? Which would mean that the bigger the status difference, the more negative the evaluation will be. If you look at the data, what you find is a plot like this, right? Again, this is still Wikipedia. And what's interesting here is that is this, right? That you have this kind of dip at 0, which would seem to suggest that people are most negative to the ones of the similar status, right? And then you have this rebound here when a high status person evaluates a low status person, right? So the question is, you know, why is this true, or is there something else going on? And what I'll show you is that sort of this is the effect of several biases, right? So this is not a mercy bounce or something, right? Because the way you could see this is, you know, when a grad student, so this is when a grad student evaluates a paper of somebody famous. This is when grad students evaluate each other papers, and this is sort of when a high status person evaluates a grad student and says, here is still hope or something, right? And really what is the explanation for this behavior is that this doesn't sort of happen because users being tough on each other, right? So here you could say people of the same status, they are at the same stage of their careers, so they will be tough on each other. We know that's not the case because we know that with similarity, probability of adding a positive vote increases. But the reason why you see this dip is because of sort of this selection effect on the people who show up, right? Sort of the high status people that show up, they basically give you this bounce, right? So they don't depend on the status difference. They show up to the election, and that sort of gives you that second bump after the decrease. Sorry?
I didn't understand that.
So the question is, why do you see this, right? And the reason why you see this is because for this range, people are similar. Because people are similar, they are positive, so you will get.
So if you correct it for similarity, you wouldn't see it.
If you would correct it for what do you mean correct it for similarity?
So you would correct for the fact that people you would say fix everyone with the same similarity, or somehow you correct for the fact that similarity raises the.
That's exactly this plot, right? These are people with high similarity. These are people with low similarity, right? So that's sort of.
But you could try to do that with a regression.
I could try to do that.
You put these together, you would predict a curve, and then you see whether this curve you see is statistically significantly different or not.
Sure. Are you using regressions in this paper? Or not?
No, I'm just doing these plots and comparing things. Okay, so let me now show you what useful thing, sort of semi-useful thing can I do with this, right? So before I was taking, how do I take now all these votes and somehow aggregate them into something useful, right? So really, what I would like to do is I would like to take these evaluations and somehow summarize them, right? Why would I want to summarize or aggregate them, right? Maybe because I want to have some kind of, build some kind of rankings of users or items, or in our case, maybe because these multiple evaluations lead to some group decision, like whether at the end this candidate got promoted or not, right? So what I would like to do is ask, how can I aggregate these evaluations to obtain some kind of notion of what's the opinion of the community, right? And really what I will be doing is I'll be asking more. I'll be asking, can I guess the opinion of the community from sort of a small fraction of the makeup of that community, right? So here is what I'll be trying to do. I'll be trying to predict Wikipedia election results, but here is how I will try to do that, right? First, I will only observe identities of the people, but not how they voted. Okay, so I only see who were the people that showed up to vote, and I won't see everyone. I will only see first 5 people. Okay, so an average election of Wikipedia has around 50 votes, so I will see first 5 people, their identities. My goal will be to say, will this guy be elected at the end or not? Okay, so that's the reason why this is kind of interesting. It's hard is because first I don't see the votes, and then the second I don't see who are all the people that show up.
But you also analyze it if you just tried to predict it from the 50, all the people that voted?
Predicting out of all the people that voted is easy because sort of it's a deterministic process, right? At the end, it's
the order, I see.
They somehow, there is still quite a bit of variation, but the good cutoff I think is around 80%, right? So. At the end, the decision that community makes sort of depends on all the votes, but sometimes, people get elected or not
Do the last
differently.
5 people give a different result?
I think they would actually, because of that selection effect.
Mm-hmm.
We see that sort of high status people usually show up early, I think. Let me show you how we do this. Okay, so here is what I would like to model. I would like to model what's the probability that user A will vote positively on this user B, in this election B. And the way I will model this is, I will estimate this background probability or the baseline probability that A gives a plus, gives a positive evaluation, plus something that will sort of try to correct for who is the candidate. And the way I will, what this means is basically is that this D of S and sigma is the average deviation in the fraction of positive votes when, users A evaluate a user B from a particular S delta quadrant, right? So what I will do, I will take this status similarity space and I will break it into four quadrants. And now for each of these 4 quadrants, I will estimate on average, how much does the probability of giving a plus change from this baseline over all the users when they evaluate a guy in a particular quadrant, right? So in my sort of training phase, all I will do is I have to estimate these 4 numbers. Okay, make sense? And once I know this, so sort of other parameters of the model, parameters of my model are this p sub a. For every user, I want to know how positive that user is overall, and then the other set of parameters are 4 numbers that sort of correspond to these 4 quadrants. Yeah?
So to use this in like a real setting, do you know how many total votes you have? You just measure like the first 5 in sequence and then make a prediction, and like you learn how many people are going to vote in this item or this person?
On average, I have around 50 votes.
Okay, so you assume it's kind of like around there the whole time.
It lives around there. Usually, what also happens is that the negative elections usually have a bit fewer votes, and positive elections are a bit longer. So there is some bias in the election length. But here I'm sort of ignoring that because I'm just taking first 5 votes. Okay? So now I have this probability. The way I will predict whether the guy got elected or not, I will sum up my estimates from 1 to 5, and then I will say, if this is bigger than some threshold, predict the guy will get elected, and if not, predict he's not going to be elected. Okay? So here is how well this works, right? So this is the number of votes I see, and here's my prediction accuracy, right? So the idea is, the number of voters I see, not the votes, right? So I see how many people, I see the identities of first 5 people, and with 71% accuracy, I can predict what will happen with the election. If I would be guessing, the success would be 52%. If I would be training some logistic regression, about half of elections succeeds, half don't, right?
But I wonder why 52 and not 50, but anyway, go on.
I didn't subsample. I think this is
you didn't subsample.
Yeah, this is the real,
Okay.
right? So if I would do some logistic regression with many features, this is how I would get, and if I would see the first k votes, this is how well I could do, right? So now if I see also the votes, then I can do sort of 85, right? If I don't know, I do worse. Sorry?
Why is the logistic regression worse? What's the...
Oh, because in some sense, I didn't model. So what I did there is I put in features of the voter and the candidate, and I hope it to sort of learn. I did something that is reasonable, but what I'm saying is, if you do it the right way and actually put these biases in the model, these deviations, you do better than if you do some kind of blind feature generation. This is sort of, if you forget everything I showed you and I ask you, can you do this prediction? You come up with 20 features, throw them in, hope good stuff will happen, and it doesn't. Sort of it does, but not too much.
I think you perhaps should emphasize this logistic regression result a little more, because what it tells you is that if you know nothing about the actual quality of a candidate, you just know the externals, like status difference and similarity, you can predict.
You can do more. So here I have the status of the voter and the candidate, but I didn't throw in the difference.
Similarity to what? How do you, I mean,
to the candidate, between voter and candidate, right?
So you do logistic regression on you know the voters.
I know I know the identities of the voters. I don't know their votes.
Identities of the voters. You know all the identities of the voters, and then you do this logistic regression.
Exactly. Okay, good. So, yeah.
So that's you get from the first 5 votes. There's similarity to the guy. You look at the similarity between the first 5 voters
to the target.
To the
yes.
guy, and that's sort of a representative sample of the 50 people who are going to vote in this election.
No,
it's
the first 5.
It's the first
different.
5. Yeah.
The first 5, it's a selection bias. The higher status people.
So if there are just 5 out of 50, how come you get this result? Why should you want to? If they're not a representative sample, what do you make of this?
I mean, what I make is that there is this strong regularity or this strong correlation of status and similarity to the human behavior. Okay.
So you've seen the number of voters.
Yeah, it's really stunning.
Yeah.
So institutionally, the 6th voter sees the first 5 voters and their votes, right?
Yes.
Sees their names and their votes.
We actually looked at that. So the way we started doing this work was to say, there must be some kind of dependence of, what the 6th voter does given what the first 5 did. There is 0. Right. So we looked, for example, at sequences of 10 votes where in the 10 votes, one of them was positive. So you have 9 zeros and 1 1. And then you ask, where does this 1 occur? It occurs evenly across. Right? So if I take all the elections that will get 9 against and 1 support, and I ask, okay, where does this support occur? I would imagine, so for example, if there would be some kind of herding to occur, let's say, very late, it occurs evenly across the 10. So we did that, actually. So there is no temporal, I don't know how to say, sequential bias.
It's an interesting result because in project online in use, we know there are some very strong temporal patterns. For example, as time moves forward, then reviews tend to be more extreme.
Okay,
because people say, I'm not going to vote unless I have something which is different than people try to be.
Here we don't really see, all that we see is that sort of the elections sort of start very positive and then very slowly sort of degrade. But in the first 10, like there is nothing that you would really see from one to the other.
I think putting in an evaluation is really different from voting. Whether somebody will or won't, has something you need to say versus voting.
I'm just suggesting that there might be some patterns there.
Yeah.
It's difficult to believe there are no patterns.
Not just the relatives.
Okay, super. So here I think what is kind of cute from this is sort of this idea, right, that sort of you can say something about what the community thinks from just who the audience for that thing is, right? Sort of from just the identities of the people, you can say something about what will their reaction be, which in this case was whether the guy.
Yes, that we would be so loud.
I obviously not, because I'm at about half of my talk. Yeah.
Do you have a sense as to whether or not the outcomes of the first 5 votes predicts the arrival rate of other votes, like the total number of votes for the issue?
Here we didn't look at this too much, but we have another paper where we were looking at when people ask questions and then how do answers arrive. And there, the way you think about it there is basically that sort of first the high status people come. If they have nothing to say, sort of a bit later, the intermediate status people comes, and sort of, it's like you see who comes ordered in status. So the longer it takes to receive an answer, the worse things are.
Is there a lot of variation in all?
Sorry?
Like the length of the number of votes, is there a lot of variation in that, or is it are some of these really just 14 and some of them are 140?
No, these things are more, they have at least 30 plus votes, and some go up to hundreds and so on. So,
to follow up on that, did you try predicting based on this number?
Based on the number, what is the success of the election? That I'm sure I would get some signal there. I'm not sure how good it'd be.
We did something similar with the conferences where you have bids, where reviewers are allowed to bid for papers. And this is anecdotal evidence, but certainly a number of bids predicts acceptance very well. So the more reviewers want to review the paper,
the more. Okay, cool. I would be super happy to look at this through the conference reviewing data. Right there, I could use DBLP data as a notion of status. I can do cosine similarities between abstracts. I mean, I'd be super interested trying this. Sorry, yes.
Submit your paper to that conference.
For this, because one thing that strikes me about this is it's weird that almost exactly 50% of them get accepted and 50% get rejected. That would assume most nomination methods would either tend to be would sort of drift away from 50%. Where are these nominations coming from?
From the community.
But is there any principal reason why it should be coming out to roughly 50% accepted, or is that just sort of unexplained?
I don't have the answer.
Okay, we should let you go on, and you can go a little past 5.
Okay, so let me do the following. What if we make this agreement that you won't ask me questions for the next 20 minutes? What about that? Okay, so let me continue telling you my story then, right? So there are two more things that I would like to tell you, right? So the first thing is that so far sort of I was only interested in studying this kind of dyadic, right? I evaluate you without knowing anything else about the rest, right? So what I would like to do this is now put these pluses and minuses, these positive and negative evaluations in the context of the network, right? And I would like to tell you sort of how you can think about this here, and I'll just give you a bit of a high-level overview. And sort of what will be the point? The point will be that sort of people behave remarkably the same regardless of what is the meaning of these pluses and minuses and things like that. Okay, so now I have a network, right? Before I was just looking at a single evaluation. Now I put evaluations together and they form this kind of directed network, right? So the way how I can think of in a directed network in terms of positive and negative evaluations and status is I should also note that now I'm changing the notion of status. So now status is some implicit quantity that comes out from the network, right? And the way I will sort of define status in the network sense, right? So this has now nothing to do with edits, is that when A gives a positive edge to B, this is sort of a statement that B has higher status than A, right? So A says, you are better than me. And when A gives a negative edge to B, this means this sort of, I could think of this as B has a lower status than A. Okay, so that's one possible interpretation or a hypothesis for interpreting positive and negative edges, right? Again, just note that here this notion of status now, it's not the number of edits, is sort of implicit by the direction and the sign of an edge, right? And the interesting thing is, right, that sort of you can apply this kind of principle over paths and sort of a positive edge in one direction or a negative edge in one direction is equivalent to the positive edge in the other direction.
Transitive, right? I mean, I could think positively, and then I close the loop.
Oh yes, in the data things, I'm coming to that. Okay, but sort of if this is, then I could do this. Okay, so now I can start asking. This is one way how to think about this. Sort of the other way how to think about this sort of comes from structural balance theory from social science. And the way to think about this is sort of you come up with this kind of rules, right? Friend of a friend is my friend, right? Or enemy of my enemy is my friend, or enemy of my friend is my enemy, or my friend of my enemy is my enemy, right? And if you take these things into the language of sort of graphs, then really these are statements about triples of connected nodes that are connected with signed edges, in this case undirected. There are 4 ways how you can put pluses and minuses on a triad. The first 2 triads you call balanced because they are consistent with this reasoning. The last 2 you call unbalanced because they are inconsistent, right? This says there are 3 enemies, and here this says you have 2 friends that are enemies with each other, right? So now the question is what happens in networks, and what is also interesting about these 2 theories is that, for example, the status theory will sort of tell what it makes a prediction at the global level of the network is that network should be sort of hierarchically organized, which means that sort of, it should be approximately, right, because it's real data, acyclic, right? So you could transform all the negative edges so that they are positive and point in the direction, and then you would hope to find this kind of directed acyclic graph, where this would be sort of the guy with the highest status, and the leaves at the bottom would be guys with the lowest status, right? So that's the prediction that comes from the status theory. From the balance theory, the prediction that comes is basically balance theory ignores the directions of the edges, and if you apply it, basically what you can prove is that your network will fall apart into this kind of coalitions, where you have positive edges on one side, positive edges between the nodes on the other side, and then you'll have sort of this kind of bipartite graph of negative edges, of sort of a coalition here, a coalition there, and only sort of negative edges across, right? What you find in real data, sort of given what I told you so far, maybe this is not so surprising, is that people are really there is the aggregate tendency in the network towards status, right? So for example, in this particular case, when B gives a plus to X, X gives a plus to A will give a minus to B, right? Even though sort of these are all positive edges, from this A has the highest status, B has the lowest status, so people really give a minus here, right? Which is kind of interesting, sort of another evidence about status being, networks being organized by status. And here's another example that sort of now we have negative edges this way, and you also get a minus. What is interesting is that sort of these theories, balance versus status, they work at different levels, right? Sort of you find that balance works more on the reciprocated links, which what I mean by that, if I give a positive edge to Christian, then by status theory, he should give me a negative edge. But in that case, for example, you see also positive coming back, right? Sort of people reply with the same sign edge, which is more what is consistent with balance. But then once you embed things globally or inside triads, you see that status to be much more present. And that's sort of the thing that you can look when you look at the data. Another sort of interesting prediction task you can do is the following, right? You say, I have this A evaluating B. I want to know what's the sign of this edge, and sort of all that I know about this is in sort of in what kind of context does this edge appear, right? What are sort of the surrounding triangles? What are their signs and directions? And what you can do is basically build a very simple feature vector, right? You just for every triangle you ask, or for every triangle you ask how often does it occur, in this part of a network. This gives you sort of, there are 16 possible directed labeled triangles. You can train a logistic regression, and that will give you accuracy of around 95% in predicting this edge, right? So what does this mean? That you can sort of very reliably, based on the network surrounding structure of the network, you can predict the sign of this edge. And what is maybe even more surprising is that now, because I have this logistic regression model, I can take different data sets. I can take Wikipedia, where it's election. I can take these opinions, where it's trust, distrust. I can take this Stack Overflow, where it's up and down votes. And what I can do is I can train my logistic regression on what I will say a row data set and predict on the column data set, right? And here are the results, right? So just to tell you, for example, this is I'm testing on /dot. I'm training on opinion /dot, or in this case, Wikipedia, right? So what I see here is when I train on the same data set, right, I'm still doing cross-validation, so I'm not cheating, right? I get sort of 93% accuracy. If I train on opinions, I get 92% accuracy, right? So what is interesting is that I can train on edges that mean trust, and I can try to predict edges that, here means friend, enemy, and I can do as well as if I train on friend, enemy edges. Or, for example, here, I train on who trusts whom in online reviews, and the same model, the same coefficients and everything predicts, how people vote on Wikipedia pretty much as well as if I would train my model on Wikipedia, right? So, sort of, what's the,
What's the fraction of positive votes?
Here it's 50-50. So I subsampled these guys because I can, right? Because I'm only taking this network surrounding that guessing would give you 50-50. Otherwise, pluses, minuses, in these three cases, it's about 80-20. But here, guessing gives you 50, okay? So sort of what's my point here? My point is really that sort of you get this kind of amazing generalization of of the behavior across very different data sets, right? What's even interesting is that, for example, in this data set, these pluses and minuses are public, right? Everyone sees them. People work 2 years to become nominated, and then you go and you say, no, I'm against you, right? While, for example, in these opinions, the way it works here is that based on the trust edges, reviews get rated, sort of ranked, and then based on the number of people that see your review, opinions gives you money, right? But the funny thing is that in this data set, trust edges are public, everyone can see them, but nobody can see your distrust edges. So here, giving a distrust edge costs you 0. Nobody will see that you gave a negative edge to someone. Here, sort of socially, it's very costly. But even though sort of these are very different examples, at the end, the same model works super well across all these different data sets.
To predict, like other simpler models which give you about the same performance accuracy?
They give you worse accuracy. So I was trying something about how many pluses have you created so far and things like that, and the degrees and so on, and they give you much worse accuracy. Okay, good. So now the last thing I wanted to talk, and this is really sort of something that we are currently working on. So I want to talk about now people evaluating items. Okay, and in particular, why I think this is cool is because 2 reasons. First reason is that this is about beer, and the second reason is that these evaluations have different dimensions, right? So what we did is we crawled these beer review websites that have millions of beer reviews, and here is how a particular review looks like, right? So this is some user, he rated this particular beer. Here you can read the review. I basically don't understand pretty much any of these words, so you see the jargon is very specific. And then every rating goes, what was the look, smell, taste, feel, and overall, right? So you get 5 dimensions of the opinion. And really what we started doing was, can I, for example, go and sort of discover what words do people use when they talk about look, and what words they use when they talk about smell, and which are sort of positive words for smell and which are positive words for look, and so on. And then the other thing that I could do is, if I would want to do some kind of summarization of these reviews or collapse multiple reviews, one thing we did is we wanted to build a model that for every sentence we figure out about which of these aspects is it talking about, right? So that's my only equation I have. So basically what we did is we came up with this super simple model that says the probability that a particular sentence talks about a particular aspect, right, look, smell, and so on, given that sentence and that rating. This is the sentence in the review. This is the sort of the rating vector. All I will assume is that sort of this is some kind of log linear model of 2 types of parameters. One I will call aspect weights, and basically they tell me what is the weight of a particular aspect and a particular word from that sentence. And these are sentiment weights, which says for a particular aspect, for a particular rating in that aspect, for a particular word, what does that do to my probability of a sentence being from that aspect? And I can sort of estimate this model from the data. What do I mean estimate the model from the data? Is that I'm given a sentence and the rankings, right? So I have no supervision. It's fully unsupervised model. What I want to estimate is which sentence corresponds to each aspect, and what are these word aspect weights and what are the aspect word rating weights, right? And if I show you some results, so what we did here is we tried first to use Amazon Mechanical Turk to ask people, what is this sentence talking about? And if we asked sort of each of the aspects it's talking about, and if we used Mechanical Turk, we basically got complete noise. It was like useless. So what we did is we used this other website. That's how this is, right? So what we did is then we wanted a beer expert. So we used this other service called Odesk, and then we found 2 Danish beer experts to whom we sort of asked, what do these things mean, and they were able to answer. So we were able to hire two beer experts from Denmark who were able then to sort of label quite accurately what sentences these things talk about. And then basically what we did is, given the review and the ratings, we in an unsupervised way, we learned these correspondences and then said how good are our accuracy. And sort of we can do with our accuracy in matching sentences to the aspects they talk about in this unsupervised way is 0.8, which is quite nice. And then the last thing I'd like to say is if you look at the parameters of the model, you see you learn quite a lot, right? So for example, these are the word clouds for feel and look. So these are the two aspect dimensions. These are the aspect words, right? These were my my thetas, and these were my phi's, right? So these are the words that have high weights when the rating was 2-star, and these are the words when the rating in that dimension was 5 stars, right? And what is nice is that sort of here you see that the words that appear here are mostly nouns, but then sort of these are the sentiment words, right? Sort of when you talk about feel and you will give 2 stars, you use watery and thin, right? If you will give a 5-star rating, you will say perfect, incredible, amazing, you know, silky and velvety and perfection and so on, right? And you know, this is now for look. You say it's cheap and yellow and corn and water and some other words. Actually, we didn't want to show one word review, like one word, 1-star words, because those are sort of not to show. But 5 stars are nice, right? So this is sort of some fun things that you can do with the reviews. So basically, let me now conclude, right? So really, what I wanted to tell you in this talk, and hopefully I conveyed some of my message, was that sort of in many situations, right, opinions and evaluations are expressed, but sort of it's good to understand what kind of underlying principles drive them, right? And through this analysis of status and similarity, at least I was trying to provide sort of some basic vocabulary, you know, for dissecting fundamental ingredients that go into this process. And hopefully I convinced you at least a bit, but you can also should read our paper, right? And sort of, right, what I was talking about is, you know, status and similarity, and kind of this interesting difference between, you know, agreement, whether agreeing with someone or saying that something is correct, right? And then we looked at this group decision process and how sort of how strong are these status and similarity biases in let's say determining the outcome of a group decision process, Wikipedia elections in our case. And I think the interesting theme here was sort of, you know, what can you say about the content from the audience composition, right? An example, this anecdotal case from conferences is maybe something like that, right? If lots of people bid, that's already a good sign about a particular paper. So what I wanted to say, right, is that sort of in online domains, right, I showed you that sort of people apply multiple dimensions in evaluations, right? Many times sort of all we can do today is just like things, right? And one thing that I sort of didn't talk about, but I think it's kind of very interesting, is then talk about, you know, how these evaluations create incentives in terms of, right, sometimes even unfair evaluations can produce certain kinds of outcomes, you know, what kind of status and reputation mechanisms should be built into these systems, you know, to achieve, let's say, truthful or desirable evaluations. And just sort of the last thing I wanted to show was to say, right, that what I wanted to sort of show you is that by doing this kind of empirical data analysis, right, at least this allows you to form some hypothesis or dissect sort of the forces that work when, let's say, people do make evaluations. But here is the funny plot I will end it with, right? So there are many other factors, right? So what I'm showing you here is time of the day versus average beer score. And what you learn from this is that the beer tastes the worst at noon and tastes best at midnight. So, you know, maybe that is also how drunk people are. But with that, I'll end. So thank you. But I'm happy to take questions also.
So going back to the Wikipedia e-opinions, how well would you do if you just look at the votes without knowing the network structure?
How well would I do? What exactly you mean? So if I would know, like here I didn't know anything about the votes. I just knew the network. I didn't know anything about the rest of the users. So you're saying if I would know based on the status and similarity, if I would go to predict individual votes, how well would I do? That's your question, or?
No. If you knew the first 5 votes.
If you knew.
Yeah. If I know the first 5 votes of the election, then I can predict the outcome with 85% accuracy.
So Sorry, not the first prediction that you showed us. When you calibrate on your opinions and then go to Wikipedia.
Yeah.
I don't know who voted for who.
There, in that case, I was predicting individual votes.
Okay.
Right, so I was really asking, how will this guy evaluate that other guy? All I know is in what kind of triangles does this red edge occur. That was all I knew. Okay? Yeah?
Yeah, so it seems to me that the reason why this prediction, the accuracy is so high is that, in fact, you're using all of the aggregate data about how a person like this votes on a person like that. Is that essentially the reason why just knowing the identities, it's that nothing is new under the sun. If I know how this person voted on a person like that before, I also know how this person would vote on a person like this again.
Sure. You are exactly correct. Just a priori, it's not clear what does it mean on a person exactly like that. What I sort of showed you is what are the two dimensions that you need to consider. One is status and the other one is similarity. But then basically the rest, if basically people say, how similar am I, what's the status difference, and then they make the decision. That seems to be the two major forces that are behind this. So that's a good way to summarize.
This slide speaks to the question I sort of had throughout your talk, which is how do you assess what amount of voting differences is accounted for by status and similarity, and how do you determine which factors you're going to take into account? I mean, could you have picked two other qualities like sex or height or other kind of what part of the country they live in, or it seems in this case you've got time of day suddenly having this huge effect. How does that?
This is a joke.
Well, I realize it's a joke, but it also demonstrates that there are other factors that influence how people rate things. Right?
Yeah, sure. This is more than using the plot.
That the ways people, when anybody evaluates something, certainly similarity and status are going to play into it, but there are a lot of other factors that will play into it, right?
Sure,
like how do I feel that day, and what's the weather like, and a lot of other variables. So my question is, how do you determine which variables you're going to use as the ones that are going to be considered the potential causes in this, and how do you account for what proportion of the difference is accounted for by those variables? If you can say 95% of the difference in voting is accounted for by similarity and status, then I'm like, wow. And if you say 5% is accounted for, then I want to know what the other 95% are.
I think that's a valid question. I think one way that we tried to get into this was doing these predictions in Wikipedia elections, right? And a priori I don't know what it's not clear what other features I should put in there, right? But by using these two features and sort of very simple model of how people's behavior changes when they evaluate other person of certain similarity and status difference, there was this huge boost in predictive accuracy. So those are definitely two useful features. Now, if there are others.
So how did you choose those two in the first place? Is it because of the literature on what motivates? Or why? I mean, I realize that those are two that obviously are relevant, but there are others that.
Oh, the way this was done was first, actually, we started looking at signed networks, and we found that balance theory doesn't work. So we were saying, okay, can we come up with a better theory? And then we sort of came up with status theory, and we said, oh, look, status theory works. Then we said, okay, and we saw that we can predict these edges, and everything was good. And then we said, okay, let's go back and try to understand this dyadic relationship. And we said, we were looking at Wikipedia elections over time, and then we said, okay, let's use this proxy of status, which is number of edits, and we saw this strange dip, and then we started saying, okay, let's explore what this dip is doing, and then the similarity came into play and so on. So here was I showed you a straight line. We were doing this for quite some time.
So what are in your question, what are the actual design applications? Like, what would you do differently based on?
I think there are a few things, right? One thing is if you ask, for example, when you compute averages of, every star ratings, rankings, and so on, you could try to at least go and as a designer or owner of these online applications, similarities, statuses, right? It's sort of the things that happen in that closed ecosystem, so it's easy to obtain, right? I didn't use any external features of those users, and that may allow you to, for example, more accurately in some sense, compute unbiased averages of stars, for example, and then have better rankings of products. Another thing you could start doing is this, that maybe given this a strong correlation between who shows up to vote and how people make their opinions, maybe you don't even need to have explicit feedback mechanisms. Maybe all you need to do is watch the audience structure and be able to say something about a piece of content and so on. So I think those are sort of implications that you can take home.
One or two more questions?
I think to really predict, or to really be able to talk about what's the opinion of the community, you need to be able to also predict non-voting. Because I think that for you're predicting the difference between voting yes and voting no, conditional on voting. But I think for a lot of voters, probably the more important margin is between whether to vote or not, or whether to vote positively, or whether to vote or not, whether to vote negatively. So you can predict whether they have a positive and negative opinion, conditional on them having a strong enough opinion to vote. But if we want to know the opinion of the community, it's important, I think, also to know what is the decision on whether to show up or not. You talked about some suggestive results in the first part of the talk, but in the second part, you really focused on that conditional prediction.
I agree. So in the second part, when I was predicting ad science, that was definitely for people that actually came and voted, right? Now the question is, how well would I do on people that didn't vote? I don't know, right? But for the first part, in some sense, we were interested in sort of in the final outcome of the group, right? Whether that outcome is the correct outcome, meaning if everyone were to vote, would the outcome be still the same? Again, that's a good question. So predicting participation is an interesting topic, yes. Maybe one thing I should show, if you are interested in playing with the data that we used, here's the website, download it, it's all up there, create your own plots, see if they go straight or go up or down, things like that.
Just one last question, my address.
Oh, yeah,
sorry.
Kind of related to what he was saying. One of the nice things about the system is that they record viewing even if there is no action. So I wonder how your models will change if you had access to data from Wikipedia or any of these sites that tell you whether somebody viewed the election was happening and didn't decide to vote or not.
So I don't have a case for this, but one thing that we were doing where we actually knew the voting data was on Stack Overflow. You know the question, you know the answers, and after 1 year, you know what was the page view count on that page, right? So you know how many people viewed that thing in 1 year. And there, by looking at the first, was it like the first 50 minutes of the time after the question was asked, we were able to tell quite accurately how popular the page will be or how many views will you get over 1 year period. So this kind of sort of fast-paced reactions or very short time window reactions of the community tell you a lot about what will happen to the content in the future. It was in a different context, but there the similarity was that sort of you see very quickly what's going on to a particular question, what kind of answers it got, and then you ask, okay, you know, in a 1 year period, how popular will this page be? How many people from Google and elsewhere will want to see it?
You don't know who is viewing it, right?
I don't know. I just knew the total page count.
All right. Well, let's thank the speaker once again.
All right. Thank you.